Aha, bingo. Okay, I think we're set.
Oh yeah, I just saw the live message come on. Cool.
Perfect timing. Okay, well, welcome back, everyone. This is day 2, and Luke will be starting off the next session.
Thanks, Michael. So for this session, we need to keep the timing a little bit tighter than we did last time because we're a fully booked session. So 15 minutes of presentation and 5 questions, please. And without further ado, over to Nick. Please take it away.
Thank you, Luke. Hello, everyone. My name is Nick Mulleners. I'm a PhD student at Utrecht University, and I'll be giving a small presentation of my proposal on model-driven synthesis for programming tutors. All right. So first, what's the setting? It's about. Oh, sorry.
Where, Nick, you're currently not screen sharing. If you are
yes, that's stupid. Where is it again? Yeah.
Great.
All right, is this visible? Okay. Well, my name is Nick Mulleners, model-driven synthesis for programming tutors. It's about statically typed functional programming language where we want to teach students to write recursive programs in an intelligent Turing system. So, for example, we have a function mySort, which sorts a list of integers, and we have a description, and the students should write this function in an interactive editor. And this editor looks something like this, where we see the function, and there's a button to check for feedback. So the question is, how do we give feedback? And we propose to give feedback based on model solutions. So, for example, this model solution implements the sort function as insertion sort by writing some function insert that inserts an element in a list while keeping that list sorted. And then by using fold R, we can build up the list again, but make sure that it's sorted all the way through. All right. And then if a student presses the check button, then we can tell them something. We'll try implementing it using insertion sort with fold R because they haven't done anything yet. And well, let's say that they try to implement it, and for insert, they define a function in terms of the cons operator on lists. And then the feedback would be, well, this is incorrect. We can check their solutions against some input-output examples that we generate from our model solution, and then we can conclude that this function is incorrect, and we can show them perhaps a counterexample, or maybe we can tell them the resulting list is not sorted in a non-descending order, so this is incorrect, right? But perhaps the student already has some more knowledge, and they think, well, I know binary trees, so what if I use some function tree from list that turns list into a binary tree, and then in order, which returns the elements of that binary tree in order. Well, this is a valid way of sorting a list. So we can tell them you have finished the exercise, even if it doesn't correspond to one of our model solutions, right? But what if a student is still on their way to a solution? Because we have only looked at before the student even had a solution, so before they started, and once they finished the solution. But perhaps the student is halfway there. So let's say that the student knows how to use fold R and knows how to, that the base case should be the empty list, but they don't really know how to implement insert. And this is typically the moment at which a student would like to have feedback from a teaching assistant. So if a teaching assistant is not available, we would want to still be able to give them feedback. So the real question here is, they can implement fold R using a hole denoted by a question mark, but how, what should this hole be? How should they fill this hole to still finish their solution? And in order to figure out if this is possible, if they can still finish their solution, we want to use program synthesis.
To some of us, and
program synthesis is to automatically generate programs based on their intended behavior. And of course, we know the intent behavior of our function because we have model solutions. And these model solutions are not really a concrete specification, but they have like a type signature, and we can use them to generate input-output examples. So together we have types and examples. So perhaps we can use type and example directed synthesis, such as the MIT synthesizer, which works kind of as follows. You have a signature like length from list of int to int, and then a set of examples, and then the output is a program that adheres to this specification. Now we think that this works really well for our purpose, not only because we can generate examples and signatures, but also because for general purpose synthesis, this type and example directed synthesis has like a small difficulty, which is that we require all our examples to be trace complete, which basically means that, for example, for the input list 3,1, if we apply it to length, then we expect that in a recursive case that length is applied to the tail of that list. So this tail should also be in the example set. And this way, the whole trace of the program is in the example set and not just a simple input-output example. And in this example set, this is the case. But in general, with general purpose synthesis, it's not always trivial. But in our case, it is definitely trivial because we can just generate any input-output examples on demand. Furthermore, we think that this kind of synthesis is very fits very well because we expect all the correct solutions that are generated from these student sketches to kind of resemble our model solutions, and we even want them to resemble our model solutions. So because this is a search-based synthesis, we can try to guide the synthesis by using a heuristic that gives priority to constructs from our model solutions. So all this sounds really nice, but there is still one problem because we cannot directly apply such a synthesizer to our problem. Because, for example, in this case, we know the specification for the function mySort, but that does not mean that we necessarily know the specification for the whole inside this sketch. So how can we generate a specification for this whole? And therefore, we will use live bidirectional evaluation. So I will go over what this means quickly. Live evaluation basically allows you to evaluate an expression containing holes by working around the holes. And so, for example, if we apply a folder with a hole to some list, then you can see how the evaluated expression is basically is the unfolded folder function, and you can see all the applications of the hole on all the elements in the list. All right. So then we have some expression containing holes, and then we want to apply live unevaluation, which basically say that we have some expression containing holes, and we expect a certain result from our evaluation. What constraints should be generated such that this expected result actually comes out, right? So in our case, we expect that the result will be the sorted list 1, 2, 3, and then the following constraints are generated, which maybe you already see it, are especially exactly the specification for the insert function that we used before. And these two techniques together form live bidirectional evaluation, which allows us to take some global input-output example and a sketch, and then it returns local input-output examples on the holes within that sketch. So now we have these local input-output examples, we can use program synthesis. So we use type and example directed synthesis, and in our case, we have a signature of the whole, which is a function from int to list of int the list of int and some example sets. And then we expect our output to return the insert function. And the insert function is in our scope because it is in our model solutions. So we expect that it's very easy for a synthesizer to find a solution for this problem. And therefore, we can easily say that a student working on this exercise is definitely on the right track. And we can go even further and tell them something like, perhaps you should introduce a function insert. And maybe we can give even more interesting hints, such as some input-output examples that should hold on this function, or maybe try to generate some properties that should hold on this function. But nevertheless, we can at least give feedback on an incomplete program. But the nice thing is that we can now give feedback on every program that the student throws at us, even if the synthesis process fails. So take, for example, this function where it's almost the same as the one we saw before, but the student uses fold L instead of fold R. Well, this is, of course, fine, and we can fill the hole by using flip insert, but maybe the flip function is not in scope, or our synthesizer has a depth of 1, which is really stupid, but that could be the case. So then we can tell the students no program was found within some number of steps. And this may sound like silly feedback, but it's actually often what the student is looking for, because they want to know whether their approach makes sense, and maybe they should try something else because their approach is too complex. So this is still a nice feedback we can give to the students. And we can go even, or we can sometimes go even further and tell them that their solution is completely incorrect. If the search process is exhaustive, or for example, in the following case, where the student tries to implement sort function using map, we can use live bidirectional evaluation again to generate some constraints. So we start from a global constraint, like for example, list 2 to 1 map to the sorted list 1 to 2. And then we expect our local constraints that are generated to map 2 to 1 and 2 to 2 and 1 to 2. But there's of course a conflict, because a function cannot have multiple outputs for the same input. And this clearly maps 2 to 2 different outputs. So we can tell the students that this is incorrect and they are no longer on track. So that's nice. And perhaps we want to also help them get back on track again. And that is also possible, because the problem here lies in that the hole cannot be filled. But we can kind of, if we look at the abstract syntax tree of our program, then the hole is a child of map. So we can kind of blame map for introducing this hole, which cannot be satisfied. And we say, well, maybe map is incorrect altogether. And we replace this map with a hole. And then we can repeat the synthesis process and then figure out that this is a point where the program is still on track. And perhaps this is silly because we just tell the student to start from scratch, but in this case, this was needed because their solution was clearly wrong and could not be finished anymore. But there are also other cases where we can do kind of the same thing. For example, in this case where student tries to implement sort using fold R, but defines insert as the cons operator, we can generate some counterexamples and figure out that cons is actually the one to blame. So we replace the cons operator with a hole, and then again repeat the synthesis process and figure out that now we are on the right track. So this allows us to take some student program and figure out kind of the nearest program that is still on track, and then give some feedback on how the student should continue from this point. All right. So to summarize, we start with a student's sketch, a program containing holes. Then we use live bidirectional evaluation to take our global input-output examples and generate local input-output examples. And then we use type and example-directed synthesis to generate the holes within their program from these input-output examples. And because we have model solutions, we can just generate input-output examples on demand, so we don't have to care about the trace completeness. And we expect our search to be pretty fast because we can use weights based on these model solutions. And then once our program synthesis is complete, we can try to repair the program by introducing holes where needed. All right. Are there any questions?
Thank you very much, Nick. I see Bjorn has a question.
Yeah, Nick, thanks for that presentation. Really interesting area that some of my students have also looked into for a number of years. I was just during the presentation trying to kind of collect my thoughts, what we've learned about these higher level conceptual hints to generate. So I'll just give you a brief rundown of what's on my mind. The first one is my student Ryo Suzuki had the good idea of looking at Piazza Q&A forum for an introductory course, seeing the questions that student asked and the kind of answers that TAs provided, and then trying to come up with some classification. Well, what is the TA trying to do here, right? Are they trying to show you where your behavior diverges from the nearest correct solution? Are they trying to focus your attention on something? Are they trying to get you to understand the behavior through showing you a Python tutor visualization or something else? So I think having some, taking that maybe as, I don't know if it's the gold standard, but having some taxonomy of, oh, here's what TAs do, and here's where our synthesis approach can recreate that kind of hint. It cannot recreate this other kind of hint, I think is a helpful exercise to go through. We've at some point also run a study of binary versus counterexample versus conceptual feedback. And the picture that emerged is, unfortunately, it's kind of complex. It's, as so often, it depends, like which one is the right one to show when. And it kind of depends on the problem. So I'll drop a link to that study. We did it in a different domain that's a little easier. We did it for automata. But that study might have some good insight. And then the last thing to point out is it took us a while to realize that, but one of the things you can really leverage in this domain, because you have lots of students, right? You can leverage all the data that the other students produce. So we've used that, for example, instead of relying on synthesis to give us the right hint, we can use synthesis to produce patches that transform your program into a different program, and then check it, has another student produced a correct solution that is, very close to where you currently are. So I think there are great opportunities for synthesis at different levels of abstraction. Am I synthesizing the correct code itself? Am I synthesizing a repair that transforms your code into code that is very similar to some other student that might be, correct or incorrect? Maybe then you can pair the students up. Or am I trying to synthesize a characterization of your program's behavior in some higher level language? And then I can use that to generate a hint as well. So yeah, I just wanted to kind of commend you on great job, and I'll drop some of the references to that in the chat.
Yeah, thank you very much. These are some great points, and yeah, we also maybe that's one I already saw some of this, but I know about some categorizations of TA feedback. So that's also something that I want to look into. And yeah, there are also some other techniques that we want to try to combine with program synthesis using normalization and such. But yeah, thank you. I'll definitely look into your link.
Yeah, and
Fantastic.
one last
Sorry,
perspective
Bjorn,
that
we don't really have.
Oh, sorry.
I'm
Okay.
going to have to cut you off here, I'm afraid. Please do post anything else on Discord if you want to. If anyone else has a burning question they'd like to ask right now, please post Q or raise your hand. Otherwise, can we thank Nick again and then hand over to Chris, please?
Thank you. I'll stop sharing. Yeah.
All right. Okay, sharing working? Great. All right, hey everyone, I'm Chris. As I think most of you know, if you were here before, I'm one of the co-organizers for HATRA, and I'm an assistant professor at NC State University. And I'm going to talk a little bit about some research that has been, I suppose in some ways has been going on for a while in my lab and for me as a person, but with an eye towards kind of what I feel like is still missing from this line of work and where I want to go in the future on solver-aided creativity tools. So when I'm talking about creativity tools, the motivation for me is really about these domains in which creation has the feel of kind of navigating a search space, right? There's lots of different decisions you can make when you're constructing a thing, whether it's a piece of artwork or a piece of music or a story or like a narrative, and you and there's a design space. There's a set of affordances within the tool that allow you to kind of wind up in different states according to the sort of, whatever the tool designer kind of decided are the artistic decisions that you're going to be allowed to make. So some examples include, like in architecture and other kinds of design, they have this concept of parametric design, which is literally like numeric parameters for determining the geometric properties of things that are then usually physically fabricated. Things like generative art, in which context-free grammars like L systems are often used to generate kind of organic looking trees in virtual environments. And then because a lot of the work that I do is situated in game design, procedural content generation comes up a lot. This example here is from the game Spore, wherein there's a creature creator tool that people can use to design like their own custom creatures, but that have to be somehow constrained by this creature has to actually be able to walk or move around somehow in the world, and its physics are determined by its anatomy, which the user is constructing. So these are just some examples of what I'm talking about, and my approach has at least what I'd like, kind of my vision for what I'd like this work to look like, really takes inspiration from two lines of work, I would say. One is the concept of casual creators, which was Kate Compton's dissertation at UC Santa Cruz. Casual creators were her term for tools, the set of tools that that enable this sort of rapid iterative creation from novices who are in some sense more interested in the activity of creation than in the output of what they've created itself. Like, they're not going to make money off of this thing that they've made. They're engaging in the process of creation for its own sake. And then solver-aided tools come from the PL community and have a lot of overlap with the program synthesis world, and include Amina Torlock's work on Rosette and other things like that. Yeah, so examples of casual creators first introduced in Kate's 2015 paper include small digital tools for game creation like Twine and Bitsy, which are on the screen. And things like this are, I think that they're definitely, like, these are a realm of tools that definitely already exists, and they're very, they have a lot of very successful things about them. But where I would see them kind of falling short is that they often have very kind of conventional models of computation that sort of, I think, unnecessarily restrict the expressivity. Solver-rated programming, on the other hand, is the kind of thing where you're relying on something like a SAT solver or a constraint solver. You express some property in a logical form, and you are then able to query or constrain or check properties of your programs, or generate programs with certain properties based on that kind of specification. So my research question broadly is how solvers can augment creative practitioners' ability to navigate design spaces. And I want to do a little bit of a dive into two specific case studies that are programming languages that have been used for procedural content generation. And I'm going to focus on procedural text generation specifically because I think it's easy to give examples. So if any of you have ever seen a Twitter bot before, if you've seen several Twitter bots, you've probably seen a bot made with the tool Cheap Bots Done Quick, which was a tool based on the Tracery language. Tracery is Kate's implementation basically of context-free grammars, is a sort of specialized extension of JSON. And so these Twitter bots, they're very much just like, you can generate strings with context-free grammars, and you do things like this, like the little like kind of surrealist looking projects like Autoflaneur, which generates random instructions for you to walk around an urban environment. A bunch of people have different examples that are kind of like mockeries of existing things. Like this Foley artists one is just generating very silly like things that Foley artists or sound artists might do to produce different sounds. And then because SVG is a string, and Unicode is a string, you can also do some limited forms of sort of visual art, which people have made very nice things with. So the syntax of Tracery, it's, well, like I said, it's based on JSON. So you've got key value mappings of strings. And so you can declare non-terminals as basically lists of possible expansions. I will share the link to these slides right after the talk. I meant to before, sorry. But this link goes to Tracery Writer, which is a web editor that you can use to play around with some of these examples. Then the only like specialized syntax really, or the only like, I would say key like part of core Tracery that is specialized syntax is surrounding tokens with hash marks, which then invokes the non-terminal, so represents the non-terminal, which will be expanded with one of the elements chosen at random, one of the potential expansions chosen at random. Tracery, and along with a lot of Kate's other examples that she studied that other people have made, follow, she kind of collected a bunch of these design principles for tools that really lend themselves well to this kind of autotelic or self-motivating creation process. And they include things like instant feedback. These are, a lot of these are kind of UI principles, like no blank canvas is, essentially is a pretty well-known thing. Like you want to have some affordances in your tool so that people aren't just staring at a blank page with no idea what they can do. Limiting actions to encourage exploration. The chorus line, which is the idea of putting lots of examples of output on the screen all at once to show you kind of what the range of output looks like at least a crude approximation. And then these last three are kind of related more to community, but are about so how people will share code and examples with each other. So saving and sharing things that they've made, having a hosted community where people can post to forums and kind of share those things with each other is really helpful. And then the ability to mod and hack the underlying system and have activities in which these things happen and people are also teaching each other things is a strongly positive design pattern for this. So some of these things I think have implications for language design in particular, can kind of be translated into that. So limiting actions to encourage exploration, I would say, kind of comes across in Tracery as the fact that it's a very small language. So basically just has non-terminal definitions, expansions, and it does have modifiers, which I didn't show in my example, but you can prepend an A or a V to a word, which will ostensibly do the right thing with vowels and whatnot, A versus an. You can capitalize words, you can inflect verbs and things like that, basic like kind of language things that you might want to do. And then there's also some functionality for basically having nested environments, or where you can store the result of an expansion and then reuse it so that it's the same every time you refer to a particular term. So that's kind of one example of a casual creator principle. Another one is so if we then think about this concept of modding and hacking, I would say in language design, this corresponds somewhat to extensibility, right? To how much you can basically implement your own functionality that doesn't exist as a part of the core that already exists. And unfortunately, this is kind of, I would say, where casual creators start to experience, I would say, a tension in their principles, where if you really want to limit what people can do, then by the time they, so this part, right, this little like very shallow learning curve here is where you're learning tracery, right? So that's not very hard at all. And then you're kind of stuck here in terms of what you can do. But then if you want to, kind of at some point you hit this cliff and you're like, well, okay, if I wanted to, for example, impose a constraint, like I want to output poems where the lines rhyme with each other. Now that's not a feature of Tracery, and it would be potentially easy to add, but you'd have, basically have to go, it's like the answer is then, okay, go learn JavaScript and write your own extension. It's open source, sure, but that's its own whole skill set to learn. So logic programming is a different starting point for this, and I want to start by saying, okay, well, it's easy to do with a very short logic program, kind of a definition, assuming we have definitions of the sub goals for what a couplet is in a poem, right? So lines 1 and line 2, lines L1 and L2 form a couplet if they're both valid lines, if they both have the same meter, and if L1 rhymes with L2. Answer set programming is a particular form of logic programming that is you can use in a sort of non-deterministic way, because it basically gives you sets of what are called stable models. And if anyone's interested, I do have a primer on how ASP works at the end of this, but didn't have time to fit it into this talk. So it essentially does this through something called choice rules, which are exemplified here with this curly brace syntax. And the ones on either side basically are saying, produce exactly one atom of this form for each of the things on the other side of the turnstile. So just as an example of kind of like the full expressivity of choice rules, you could, for example, populate a grid of tiles of different colors by saying that each tile has to have a color, right? So you say this can kind of be read for every tile, capital T tile, tile has a color if that color is a valid color. And there's exactly one such has color fact for each tile. And this can then produce various different answer sets that include all the different assignments of colors to tiles. So the workflow that one would use with answer set programming is essentially, I think of this as kind of an extension of a co-creative or a mixed initiative programming process to an extent. So you author your ASP program, you run it through your solver, you get a bunch of examples, and then you sort of evaluate them somehow, either by taking these big like walls of text of predicates, answer sets in predicate form, and running them through some kind of rendering tool to see what the space of things is that you've generated, and then kind of based on that you can look at the examples and say like, oh, I didn't want to produce this is generating for me things with the right with like where the last syllable rhymes, but I want something where there's an internal rhyme as well, right? You can then kind of refine and say, I want more constraints. So you're kind of gradually sculpting this generative space to shrink down to the set of things that you want to allow, and in some cases to expand to the set of things that you accidentally ruled out that you want to include. You can also, it's important to note, like as people who've talked about solver-aided tools use, and as the previous talk mentioned as well, this is a bidirectional kind of way of doing things, right? So you can, on the one hand, you can do synthesis by saying, here are some constraints, please give me examples that meet those constraints. And on the other hand, you can put forth some examples and some queries, and then say, please, like using the same core of rules that relate examples to their properties, you can then say, okay, please answer my queries and do analysis in this way. So there are two projects from my lab that use this approach. One of them is a game generator called Gemini, and the other.
Sorry, Chris, we're running close on time.
Oh, sorry.
So
when did I
if we
start?
could at 20 past.
Okay, so I'm at 15 minutes now, right? Okay.
Yeah. So if we could head towards questions soon, that would be great.
Yeah,
Thanks.
absolutely, sure. So basically the research questions here break down as in terms of kind of wanting to understand better what the types of questions people have when they're exploring a design space during the creative process, what limitations they realistically face when using existing creativity tools, and with the hypothesis that logic programming in ASP might be a good starting point, what are the usability challenges there, and how can we potentially scaffold these tools to support creative inquiry. I'm gonna skip over that. I did want to. I had like one slide on this because I feel like this connects to things a lot of people in this at this workshop are interested in. I have a toy language I'm trying to design called Zestina, which takes this metaphor of dependent types as generative spaces and draws from work on deductive parsing to kind of use that to specify grammars like you would in Tracery, but then use the dependent types mechanisms more like logic programming to specify constraints. And it'd be really cool if we could do some kind of, like my dream like text generation language would also have a structure editor and some kind of inline synthesis like they're doing in Hazel, which I think is very cool. So yeah, this is a bunch of work that I don't have time to talk about, but basically about like analyzing the generative space. And then just to conclude, I'm really interested basically in trying to, and I think it's important, it's kind of a call to action that I think we should do more studying of creative practitioner communities. And that doesn't have to mean like studying software engineers at Google, right? This is, there's a group that does a jam every year called ProcJam, where they write procedural content generators, NanoGenmo, which is the generative analog of NaNoWriMo, where you generate a 50,000 word novel in the month of November, going on this month, and Roguelike Celebration, which is a conference of people who make roguelikes, which are games that use procedural content generation. So that's it. Please feel free to get in touch if you are interested in this work, and follow me on Twitter, and that's it.
Thanks so much. A fantastic amount of material packed in there. It's great.
Thanks.
Will, I see you have one quick question.
Yeah, so that was a really awesome talk. I'm curious what your perspective is on the role of statistical models in the sorts of applications you're looking at. Because, in the limit, there's like GPT-3, which has been used for AI Dungeon and all sorts of fun generative things. But then, with more user control is something like probabilistic programming. Like I know Daniel Ritchie at Brown, who does a lot of really cool graphics applications where it's like grow a tree, but it has to be bounded by not overlapping with some interesting object.
Yeah.
And so it's like a mixture of like random generation, but constraint bounded, so that way you don't you can meet some interesting goals. And I think your work is on like the very PL logical end of like everything is specified by the programmer. And so I'm just curious, like what you think about that. What are ways you've thought about incorporating statistical models, or if you think that would be a meaningful way to help aid the creativity of the people in your domains?
Yeah, that's a good question. So I think that there is potential in terms of, I mean, the folks who use data-driven approaches to procedural content generation still have a lot of these same questions of how do I understand the possibility space of what I can generate? How do I understand, ideally the probability distribution of things that I'm going to be generating? And so they're also kind of answering very similar questions, I would say. But yeah, I think that but you're also in that case, I find it sometimes a bit frustrating because you're faced with some questions that are, like, oh, how do we just like make sure that when you want to produce a very structured thing, like a data type representing a video game level, right? It's like, what the format of that is. You can just communicate that knowledge directly. There's no reason you should have to, it's like there's kind of basic well-formedness properties that you have to be concerned about when you're generating things based on language models like GPT-3 or whatnot that you don't have to be as concerned with. And then you also have these additional concerns like what is the corpus that you're training on, and does that reflect the kinds of things you want to generate, and does that unnecessarily constrain the set of things that you might like to generate to only reflect kind of things that have been made in the past rather than things that are new. So yeah, I suppose I have some skepticism about those methods, but I also have some interest in them and some hope that there are overlapping concerns.
Fantastic. At this point, I'm going to ask other people to move their questions over to Discord, because I think it'll be great to leave the trace of that discussion behind us, I think. So if we could thank Chris again, and I will ask Richard to pick up presenting, please.
This thing is working, right?
That's working great.
All right, cool. So hi, everyone. I'm Richard. I'm a PhD student at UC Berkeley, and I work on design tools and electronics following a PL plus HCI plus electrical engineering approach, which will be what this talk is about. So I'll start with why this application domain is important. Chances are you already know that most modern applications are built on circuit boards, and design improvements can help make better devices. But also, board design has recently become much more accessible. So fabrication services like Oshpark shown here are inexpensive and friendly, which vastly expands the reach of non-professionals. And it's this combination that motivates the rest of this talk. Can tools inspired by PL and HCI and electrical engineer approach both allow experts to work more efficiently and democratize design? So I understand that most in the audience are not electrical engineering experts, so I'll spend a bit of time going over current practices as well as summarizing the landscape of recent work. I'll then talk about polymorphic blocks, which is a prototype board level HDL we presented a month ago at WIST, and end with open questions and moving beyond these prototype systems. So mainstream tools today start with schematic capture, where the user draws a schematic. In KiCad, a popular open source PCB suite, one starts with an empty schematic, then adds parts from a list, places them on the schematic, and wires things up. Then design continues with board layout, which presents a physical view of components on the board. Here, users can move components around and draw copper wires. And with a completed design like this, the boards can be fabricated, assembled, and tested. Or that's the design story if you focus on a view of tools. So 2 years ago, we interviewed device designers, including hobby and professional users, about their overall views on the overall flow. And for schematic design, they weren't too enthusiastic about it, and concerns about aesthetics were as common as circuit design and functionality. And one common task involved transcription from datasheet reference circuits. More critically, this is the full design flow that we synthesized from the interviews. And the process actually starts with ideas and specifications, which range from user stories to technical requirements, which were often expressed in natural language and happen outside of these board tools. These ideas were then refined into a system architecture, which starts to map out the how of the thing can be built. This was often represented as a block diagram with a mix of high-level parts like generically microcontroller and specific part numbers. And the freeform nature was important, and these diagrams were often drawn on paper or with graphic software. Part selection happens throughout the entire process. Major components might have been selected in the previous architecture phase, while generic components like resistors might not be picked until schematic capture or even parts ordering. And this is the most important takeaway, is how little of this whole process is supported by PCB design tools. And these tools typically support the less interesting work, like data entry and transcription. They don't help in the more interesting tasks like architecture design or even circuit design. And it requires significant electrical engineering expertise to design functional circuits. So overall, in current practice, mainstream tooling largely ignores higher level design. But let's take a look at where things are going. So overall, I haven't seen much innovation on the schematic side in mainstream tools, and instead higher-end commercial tools seem to be focusing on improving layout and recently verification. There have been some smaller commercial module-based design tools, but these don't appear to offer the same generality, preferring a walled garden approach. Recent research work has focused on novices, with more ambitious tools looking at circuit synthesis and behavioral design. And while focusing on novices is important for democratizing design, we'd also ideally want tools at scale. And even for novices, are we just flattening the learning curve, or are we just pushing back the spike? In the adjacent digital logic domain for chip design, hardware description languages like Verilog have been common for decades. However, because of limited parameterizability, designers often have turned to ad hoc metaprogramming approaches, like the dumpster fire that is writing Perl to write Verilog. Recent languages, like Chisel shown here, have focused on structured hardware generation, such as embedded domain-specific languages using their host language for this kind of hardware metaprogramming. So overall, as far as circuit design is concerned, we really haven't moved past schematics. And while recent academic work for boards focuses on novices and might not scale, perhaps we can learn from chip design languages. So fundamentally, we'd like tools to support the more interesting work. Ideally, we might want tools to go from idea to schematic, but this might be too complex for current technology. However, the system architecture level of design might be the sweet spot. For humans, it's high level enough to be friendly, perhaps even enjoyable, while limiting much of the tedious and difficult bookkeeping tasks. For computers, it constrains the design space enough to avoid a large search space. And this is largely the approach that polymorphic blocks follows, which I'll describe through this example device with a microcontroller and LED. We built on top of the augmented block diagram from earlier work, which contains blocks, here representing components and subcircuits, ports, which represent pins, links, which represents connections between ports, and parameters, which model physical quantities like voltages and currents. This basically almost looks like a schematic, except with the addition of links, which you can think of as a typed connection that provides rules for how parameters propagate. So for example, the power link shown on the right would represent a constant voltage wire and can check sinks voltage limits against the source's voltage output. Next, block hierarchy allows us to bridge the high-level architecture and low-level schematic. While the architecture asks for an indicator LED, that block is defined in terms of an internal discrete LED and resistor. Flattening the hierarchy and simplifying links provides a schematic on the right, which is equivalent to what is produced by schematic tools. And this top-level architecture maps well to an HDL, with block declaration lines directly translating into blocks, and connect lines directly translating into connections, with links being inferred by the types of connected ports. But solely a format shift from clicking schematics into typing text doesn't really help us fundamentally. And this is where the power of programming comes in, allowing us to define components programmatically. In the indicator LED block, we will now define resistance using the input voltage. So instead of manually punching numbers into an external calculator and then punching the output into a schematic, it's now done automatically and, equally importantly, kept consistent by the tools. Furthermore, this separates interface from implementation by encapsulating expert knowledge into code. You don't need to know how to size the resistor to use this indicator LED. You just need to instantiate the block. And fundamentally, this leverages separation of concerns. Experts can focus on encapsulating their knowledge into reusable blocks, while novices can use that output as a black box. And while this LED example is kind of trivial, the concept applies to other subcircuits like switching power converters. And looking at the more complex example of a power converter, another opportunity for abstraction is by a type hierarchy. A power converter is a class of several devices, including several topologies like buck converters, which in turn have variations down to their choice of controller chips. And crucially, not all devices and designs care about this specific choice. If we use a more abstract block, that captures the design intent and preserves the design space. To go to a final circuit, we would eventually need a concrete choice. Our current implementation allows a system-level designer to make these choices, but in the future, tools could search and optimize the design space. To make sure all these worked, we produced these practically useful example boards. The top-level HDL is structured much like a system architecture diagram, and the libraries do the heavy lifting by providing microcontroller subcircuits and power converter generators. To gauge usability, we ran a study focusing on realistic usage and recruited 3 participants with board design and programming experience. Participants spent on average 5 hours to get to a schematic equivalent. Participants did like the higher level of design and libraries, which helped reduce datasheet reading and helped avoid subtle mistakes. Participants also found the electrical model checks useful, but also noted that the model isn't comprehensive. Furthermore, while generators and part models did require more effort to write, these had the benefit of reuse and shareability. And in the larger picture, participants expressed concerns about trust and quality for community libraries. So overall, we built a prototype HDL that improves design by automating with generators and abstracting with type hierarchies. And while promising, it's just a starting point, and there's a lot of unanswered questions. In particular, we think there's much we can learn from the PL community to avoid remaking old mistakes or reinventing the wheel. First, keep in mind that the target audience for this tool is device designers. Mainstream tools might feature scripting interfaces, but these are quite simple from a programming languages standpoint. Bearing that in mind, what programming languages concepts might translate intuitively to the hardware domain, or are so powerful that it's worth the learning curve? So for example, the type hierarchy appears to apply, though somewhat imperfectly because of additional physical limitations. And going further, might advanced type constructs like union and intersection types also be useful, and what might be trade-offs for using those? Programming languages has also done much work formalizing semantics, but board compilers are largely implementation-defined, ad hoc, and based on intuitions. So one question is, what kind of formalisms might make sense here? And also, just as importantly, can these be actually useful to end users as a form of documentation? And in the larger picture, no matter how hard we try, we probably won't get everything right the first time. But for a library-based tool, we also can't break those libraries every time we realize, for example, that a resistor also should have had a temperature coefficient field that it didn't before. So what usable patterns would enable designing for forward compatibility? And moving towards programming environments, our user study participants basically asked for a tighter block visualization integration, making the analogy to an IDE. And these views could surface information less obvious from the HDL, particularly connectivity data. So building something like this side-by-side live visualization is kind of a no-brainer, but easier said than done, right? Like everything. And what language features or restrictions might support this kind of tooling? And more ambitiously, can we move past visualization and full circle into graphical editing tools? And these might behave similarly to familiar schematic editors while still being able to leverage HDL libraries. And this could also be an on-ramp to working with HDL, though there also might be the question of whether it's worth it, for who, and why. And for this last item, I'm going to take a step back and point out that languages are just the foundation. In software, the real power comes from libraries, typically written by large and vibrant communities. And we expect the same for this kind of HDL design flow. So the question is, how can we encourage this kind of community? And in particular, during our interviews, correctness was a primary concern when discussing community libraries. Unlike software, fixing bugs in hardware is not cheap or easy, and verification is made more difficult by part vendors often not supplying simulation models or even comprehensive datasheet parameters. And technical approaches to correctness aside, it might be worth reframing this as a confidence and trust issue and exploring social approaches. So a starting point might be, hey, this thing has been physically fabricated and verified, just add that tag for libraries. Though a question there is, can we scale past single instances to generators? So in conclusion, there's still many continuing open questions about designing a board level hardware description language well. So main points are what PL concepts can improve foundational models, especially considering forward compatibility. What IDEs or tooling in general can help, and how can we encourage community and libraries like in software? And ultimately, we hope that these board level hardware description languages will have a bit of something for everyone by democratizing design while enabling experts to work more efficiently. And looking broader and abstracting one level up, the core idea of libraries, generators, interfaces, and higher level design probably applies to other domains too. So what might a HDL approach for a mechanical CAD look like? Or perhaps we can even apply some of these usability and programming environment tools here back to digital logic chip design. And that's it. Thank you.
Thank you very much, Richard. Very interesting topic, and I know that hardware design is of pressing concern to a number of others in the audience. I see Michael has a question.
Hi, thanks for the talk. Really interesting work. Sometimes type systems are thought of in terms of errors that they can rule out or prevent. Other times in terms of their benefits, in terms of documentation or specification. I wonder what your experience was in the user study you did in terms of mistakes people made or things people were confused about that a type system might try to address.
Right. So in our prototype system, we had a reasonably strong type system. I mean, think of it as like analogous to Java rather than like Python. So when you tried to compile a board, if you made connections between incompatible ports, it would just fail to compile and tell you like you can't connect a voltage source to a digital sink. So one piece of feedback there was that this is much stricter than current tools. So current tools, everything is a wire. It, for the most part, doesn't understand what types of wire it is, minus a very coarse type system. And one thing participants wanted, or at least one participant wanted, I think, was just the ability to connect two things. So it turns out that modeling components in appropriate detail is time consuming. And sometimes it's just like, I want these two things to connect so I can get to my board. I want to like put off the typing until later. So this could be an argument for gradual types. But yeah, I think overall, like it definitely helps prevent errors, but it does require a bit more effort. Specific for preventing errors, the one concrete example I had was one of the participants used a USB Type-C port. And because they use a library, it included the pull-up resistors that you need to for the port to provide power. And one thing they said was that, oh yeah, I completely didn't realize you would have needed those. It's great that it just automatically had them.
Okay, thank you.
Thanks. Kim, can I check? Did you have a question? I'll take that as a no. Richard, you mentioned the developers in your study said that it was kind of a no-brainer that they wanted an IDE, and that was a juxtaposed left-right presentation. I wonder if you could talk about anything else that was their expectations as to what they would get out of having one of those.
Right. So sorry, let me clarify that. They all independently asked for an IDE, but it's my own interpretation that it's a no-brainer.
I see.
Yes.
Okay.
So slight distinction. So one of the concrete things, or I think the two concrete things were that I think they felt that it was more familiar to have this kind of schematic representation. And maybe that's just an artifact of how design is practiced right now. But the other, I guess, even more concrete thing is there are certain things that aren't really obvious from the HDL view as just a bunch of connect statements, right? It's hard to tell, like, I have a block here, I want to know which ports are not connected yet. And this kind of block visualization surfaces that information very easily, as opposed to what the participants did was they would recompile, say, get an error saying this block's not connected, fix that, recompile again. So it's kind of just closing that compilation loop.
It's closing that, yeah, the different representation, closing the loop. That makes a lot of sense. Awesome. Well, if we could thank Richard again, and Hannah, over to you.
Can everybody see that?
Great. Yes, we can see that now. Thanks.
All right, so my name is Hannah Potter, and I am a master's student at the University of Michigan working with Professor Cyrus Omar. And today I will be talking about a system we are working on to guide novices through type-driven development strategies. So let's start with what we mean by type-driven development. This concept refers to the idea that the expected type of an expression at a given point in a program constrains what possible expressions could be used to fill in this expression or fix an error. For example, in this diagram, we see that the space of possible expressions is much larger when we don't constrain it by an expected type. So let's look at another example. Let's see, we've got this program and our cursor is here at the empty second branch. And we're trying to figure out how to fill in this hole in this program. And so we have to think through a lot of different types to be able to figure out what this is. And this can be really confusing, especially if you're a novice. This is also a problem if you're trying to correct a type error. So we see that there's an error on the second branch, and trying to figure out why this error happens and how this is showing up is also a confusing and difficult process, especially if you're doing this all in your head. So where can we get this type information that we want to use for type-driven development? So as we saw, a lot of it is going to come from the programmer's understanding, but this incurs a high cognitive load, especially for a novice, and it can be faulty. And we can also get this kind of information from compilers, but this information is often only given when there's a type error. So as we see in that screenshot, there's a syntax error. This is an example very much like the first one. There's a syntax error, so the compiler is not going to give us any type information to help us go off of. There are some modern IDE services, but these are often really limited or unavailable when there are parser type errors anywhere in the program. So there's this problem, there's this lack of information available when programs have parse and semantic errors. So we're working in Hazel, and Hazel solves this problem. Hazel is a typed functional programming environment where every edit state has both a type and a result. And this happens because we insert automatically empty holes stand in the place of missing patterns and expressions. So as we can see in this screenshot, there's this hole named hole 1 as the second operand of the plus operator, and that stands in the place of that missing operand. And then we also have non-empty holes that serve as membranes around type errors. So we see there's this non-empty hole membrane around this X because you can't use a bool in an addition operation. So now that we've solved this first problem of, this information isn't even available if you can't parse or if there's semantic errors in a program, let's look at the next problem. And that's how do we actually use this information that we now have available in Hazel to guide novices with type-driven development. So we're going to show a demo of our tool. So we can see here, let's frame ourselves in the mind that we're a programmer. We're not new to programming. We're like a senior, maybe in computer science, but we're new to type-driven development and functional programming. And we're given this assignment a couple weeks into this course. And we're told that we need to fill in this convert scores function by filling in these extra holes in this program. And what this function does is it takes in this list of scores and bonuses that where each entry in this list represents like a raw score and a bonus score. And we want to add 2.5 points to every submission that got the bonus question right to calculate this list of final scores. And our function needs to use this provided map function, which this is not polymorphic, just to keep things simpler for the programmer. So this is a specialized map function. And so what we see is if we're just launched into this and we're asked to just fill in these holes, like if I just have my cursor here, that's not necessarily going to help me think through this space. Like I still have to think through this space all mentally of what I could use to fill in this expression. But what we've been developing is these two different tools. This is the cursor inspector, this first line, and this gives the expected and actual types of the expression where the cursor is. And we also have this strategy guide, which the strategy guide, what it does is it gives a hierarchical view, a list of options of things we should think through when we're trying to figure out how to fill in the hole. And it's given in this hierarchy to guide programmers to go from the simplest expressions to more complicated expressions. But the idea being, if you can fill in a hole with just like, if they're supposed to be filling in a number, and a 0 will do the trick, that'll give you what you want, you should just put in the 0. Or if there's a variable that's already there that's going to do what you want, then you should just use that. And so that's how it works down and guides them through these options of, we should either fill it in with a literal of the correct type, then with a variable that we already have in the context of the correct type, apply a function to get a result of the correct type, case analyze to, maybe we need to do that on some other options that we have in the context, or maybe we need to do something else like make a new let binding. So you can see is if the programmer, if I'm sitting here and I'm trying to think through this programmer, and I look through these options, I might think, well, I don't really want to fill it in with a literal, right? Like we usually don't inline literal functions there. But there's this variable applied bonus, and this is a function the teacher has given in this starter code. Like I should probably be using that, and that makes sense. The point of convert scores is to be applying these bonuses to the scores. So I can fill in this hole, then I can move on to the next hole, and I can again look through these options and see that in the context there's this scores and bonuses. That's what's passed. That's the argument passed into this convert scores function. I want to be mapping over that list of scores and bonuses I was given. So then I can move on to fill in this other hole. And I see that what we've got here is we're trying to fill in this applied bonus function. And we see that we have raw scores and bonus scores. And we want to fill this in with a float. Well, a float literal is not really going to do the trick because we want to actually use the raw score, but we don't want to use just the raw score, and we don't want to do just a bonus. And there's not really a function available. So let's case analyze. But we want to do something else too. We want to let's see that we want to create this new let binding where we're going to say, let's calculate any additional points this person's going to get. Then we're going to take the raw score plus the additional points. And then we can continue and go through, and we see that if we don't constrain the type, because Hazel doesn't have type inference right now, then we don't get this narrowed down list of options. So it's better to add annotations. If we annotate this as being a float type, we can see that we constrain the list of options further. And we can continue and go through and fill out the rest of this function. So some research questions we're thinking through as we work through this is one of the things we want to figure out is how does this tutoring system help programmers during type-driven development tasks? And again, the programmers we're focusing on, at least as of now, are programmers who are not novices to programming, but are novices to this paradigm. So we want to think through, are these programmers able to fill in holes with an expression of the correct type? We also want to think through, are they able to correct type errors? And then we want to think through, does this help programmers understand existing codes, particularly things like APIs? We also want to understand, does long-term use of this system actually help improve student performance on assessments of program understanding? Do they actually learn these strategies and are able to apply them in the future and understand the type system better? So our planning studies are pretty early on in the design thinking through phase. Again, this is very much so a work in progress. But what we want to do is we want to make this a very iterative design process. This design is not final. We don't think this is like the magic solution. So we want to do multiple studies to evaluate and iterate on our work. So we want to perform some control studies. Each one, like you said, multiple studies, and each one would focus on a different set of tasks. So one would be focusing on understanding existing code, like I said, like in particular APIs. Another set of studies would be focused on writing new code, so that would be in filling in holes. And then a next set of studies would be focused more on correcting these type errors. And we're also planning on using this tool in the classroom in a course that we are teaching that has this population of students who are, like I said, junior, senior level students, but they've only really programmed in imperative languages before. So some future directions for this project is, as you could see, the strategy guide in the demo, the strategy guide is only defined right now for empty expression holes. But this could be useful to implement it in some way to work for type errors is sort of a debugging sort of strategy that it's trying to teach there. And we also think it could be helpful if you could pin the cursor inspector to particular expressions, and so you could track the and view the types of multiple expressions at the same time. We're also a little worried, as you can see, the cursor inspector moves around with the cursor, the idea being to keep it in the correct line sight. But we're a little concerned that potentially this could be annoying and maybe users would just hide it if it's getting in their way too much and they're seeing too much information. So maybe we'd want to investigate this in our studies if it'd be better to just dock this to this side, and that would serve the purpose better. And we also want to work on intelligent pruning. The suggestions in the strategy guide right now, it's really only based strictly on the types, which does prune down the space a lot. But if you're in a really big program, perhaps there are different ways that we could think through how to order these things and prune out these suggestions. So I want to thank the undergrads in the lab that have been working with me on implementing the strategy guide. And we have some links here where you can see, like I said, these are very much so works in progress, but we have a snapshot available at that URL, or you can look at the source code there. And then I'm going to open it up to questions.
Awesome. Thank you very much, Hannah. We have many questions arriving. So I think first on this one was Will.
Hey, so I really like this tool, and I like it, and I really like the integration with Hazel and how you can use that to essentially filter down the set of language constructs that are permissible and then present those within the dropdown. But it got me thinking, like, you used the term strategy to describe it, and to me, what language construct can you apply here is at a sort of lower level than strategy. Like if you read, for example, Kathy Fisler's paper on how novices would compose plans in solving functional programming problems, like the strategy is usually a little more task specific. And it's like, if something asks you to filter and then map a list, do you do the filter within the map or do you filter it first, right? How do you organize the respective components? And so I guess I say that as somewhat of just a provocation. It would be interesting to think about if there's any way in which you could incorporate higher order elements of strategy this gets a little closer to the tutor we saw earlier today, but like what would it mean to incorporate higher order elements of strategy or decomposition into the tutor as opposed to just individual language constructs that someone could apply? I don't know if y'all have thought about that at all.
Yeah, so the strategy in particular that we're trying to teach is how you think through this type-driven development way. Like that's the very particular strategy that we're trying to think through. And we're defining that as, you can constrain the space of possible expressions just based on the type. And so this is helping students think through that. Like if I know the type of this expression, you can actually narrow down that space pretty tightly. It's like if you talk to people who've worked in like Haskell or something like that, you know, if you can get it to compile, like it's basically like there to some degree. Like that's kind of the tricky part, is getting all these types to work out, just because the space is so constrained by the types. That's a particular strategy we're trying to work on. But yeah, like there's the possibility that there could be different tools, different sort of things that we could make available to help guide programmers a little more in like these more like high level strategies of problem solving.
Cool. Yeah, that makes sense.
Feels like the questions channel in Zoom is ending up as being holes that are getting progressively filled in. But I think if I get this right, it's over to Jonathan next.
Yes, really neat talk. This is very cool work. One question that occurred to me as I saw your example used tuples like float bool, and maybe this is just, you know, due to the you know, the proof of concept you have right now. But of course, there's lots of ways to get floats and booleans, and so especially as you start to scale up, it seems like you're likely to get a lot of choices there. I wonder if, especially with respect to scaling, it might be more effective to use nominal types, either, you know, just taking advantage of them in a functional language, or going to a nominally typed language from first principles. For example, you know, a pair of a float and a boolean could actually be a submission type, right? Would that help, you know, cut things down and give people more guidance?
Yeah, I think so. I think that points to this idea of, yeah, this type-driven development. Like, so that constrains the types, you know, more, and that would narrow down the space. So I think that would definitely be useful in narrowing down the space of what's available if you program in that kind of.
Thanks.
I wonder if the example that you gave towards the end of when you're doing programming development in a large program, simply constraining it to the types that something possibly could be is not actually sufficient, because that can be a massive imported graph. I wonder if that could represent an interesting challenge problem for the community. It seems to have a bunch of the things that Chris was talking about this kind of dynamic of a space that we're shaping, both with generative tools and with logical reasoning tools. I wonder whether one of the things we found in code completion studies in the past was that developers start to get sensitized to kind of this thing is not behaving in the way I expect, and that is telling me an implied error about something else I'm doing is not pushing my tool into thinking like that. I wonder if you've seen any examples of that kind of reasoning happening within that space particularly, or within the tool more generally.
I'm not sure I understand your question.
Sure, sorry, so I guess I'm at, yeah.
So this tool in particular, we're focusing on novices. Like I said, not novices in like the strictest sense of programming, but in novices, and like we're teaching them, so they're going to be working in like this much smaller space. It's definitely an open design thing that we're thinking about. Like, what would this tool look like? Or is there something similar that we can maybe do for more experienced programmers who are maybe working in a bigger space? Because I think that's definitely a separate set of needs that you would need. And like you said, yeah, you'd be working in much bigger programs. There'd be much bigger space, more types. Like this, we don't believe like the strategy guide would necessarily really be helpful in that kind of space. So that's definitely an open thing we're thinking about. Like, what would some of these tools look like for like experienced programmers?
Yeah, could be interesting to find out. I mean, there's been a long tradition of tools developed within CS education that in theory shouldn't be useful for professional practice, actually turning out to be pretty useful. So it'd be interesting to explore that empirically. I wonder if anyone has any other questions. Feel free to either post a queue or just to jump in.
I have one. I'm curious what your experience has been like, kind of in the following area. So some of these proof assistants have a reputation of being like proof by video game, where you can like try things, and if it works, then great, and it doesn't matter that you didn't understand it because it worked. And if it didn't work, then oops, better try something else. And then at some point you have to like think about it. If it really didn't work, Carl Kerr likes to say that thinking is plan B. And so I wonder what the usage style is with tools like this. Does it foster that kind of pattern? If so, is that good? Maybe it's good actually, because maybe in some cases it's not actually interesting and you just want to get the program written. Or does it not have that flavor? Maybe because there's the suggestions are sort of lower level.
So if I understand your question correctly, we're very like purposely not making this like show a list of options, you can click it and then move on. We don't want to promote like abuse of like hint generation. Basically, like we don't want blind clicking. The point is to show like this kind of narrowed down space of like you should be thinking through these things, and our design right now is actually like you have to type it out. There's no like clicking, there's like you have to type out whatever solution you're going to use. And with that idea being in mind, this isn't supposed to be like necessary to like click and plug like autocomplete sort of thing. Like this is really supposed to be trying to just like guide your thinking of how you do and like just helping you narrow down that space of possible things you have to think about a little bit more. So that's kind of the direction we're taking with it as of right now. It'll be interesting to see in studies. Like I'm excited to see like how useful this actually is, or if that's actually how people are using it, or maybe we need like a different interaction than what we currently have.
Okay, thanks.
Thanks. So at this point, I suggest that we wrap up this section of the formal proceedings by thanking Hannah again. Great. It's been a really interesting series of talks. I think now there is actually a break in the program, but I think if people want to continue discussing, then we're not going to close this down. So Michael, can I hand over to you to coordinate that and thank all of the speakers one last time?
Yes, thanks, Luke, and thanks to all the speakers. So yesterday we had slightly relaxed time frames for the papers because we didn't quite fill the sessions. The session was totally full, which means there may be some leftover discussion that didn't get addressed. In the next official session, which starts in 40 minutes, we're going to be sort of stepping back and trying to think about what a research agenda might look like in this area. What are some interesting problems that we'd like to address? What are some techniques that we might use to address them? But for now, we can take this informal opportunity if we want to keep talking about kind of the themes in this last session. So I'll just open it up, and if people want to talk, then you can talk. And if not, that's okay too.
Yeah, okay, I'll bite. I had a question. So I'm one of the people who's used this phrase, proof by video game. and when I've used it in a positive sense, that proof by video game is a good thing. But that appeared not to be the sense it was being used in the Q&A session for the last talk. So I was wondering if anybody's got any thoughts about that.
I don't know. I don't necessarily mean that it's always a bad thing. I mean, sometimes when people say proof by video game, they actually mean that's fun, and that's fine. That's good. If you can have more fun in your work, why not, right? Other times, and I think part of what's going on here is that some of programming is fun and interesting, and other aspects of programming are actually fairly boring because they require you to fill in details that maybe seem obvious to the programmer and that you have to specify to the machine because that's how programming works. And so, if you can remove the manual thought process from that and just, oh yeah, I know how to do this, type, done. Maybe that's easier and more satisfying than, oh yeah, I've got to go implement this thing again, even though I did it yesterday, but here it's slightly different, so I've got to redo it.
I think that the sense in which I was using it was the way in which it feels like a video game is there's a kind of like doing proof search. A lot of the time it feels like, okay, now I need to go and get the silver key from the box that's next to the elevator. But in order to get to the elevator, I need to find the key, blah, 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 blah. So that kind of sense that it feels like a video game.
So Chris, can we build actual video games that are secretly uses of making people write proofs. They don't
Totally.
even know it. They're just having fun.
Yeah, you can. I mean, a lot of video games are just linear logic proofs. Quest complete. This was basically my dissertation if I'm doing the explain your dissertation badly challenge. Playing video games is just doing linear logic proofs. But yeah, I in this conversation I think about I think David Chapman or somebody he cited has this distinction between competitive and competitive and cooperative cognitive artifacts, which is basically extrapolate the difference between an abacus and a calculator in terms of its assistance for doing mathematics, right? That you have, when you use a calculator, you have your powers to do simple arithmetic are greatly expanded, but as soon as somebody takes the calculator away, you have no idea, like you're back where you started before you had the calculator. On the other hand, if you use an abacus, you kind of learn something about the inner semantics of how arithmetic works, and then perhaps not as quickly as if you had the abacus, but nonetheless, at some rate, if someone takes the abacus away, you can still mentally go through those operations in your head and perform the operations, and it's augmenting your own ability to do that challenging problem. Like the tool is a sort of it's complementary to your human cognition. And that's sort of what I think about when we talk, in terms of these sort of proof assistants that are mostly just like automated proofs for, that give you no sense for how the proof actually works, but it's like, okay, now a chunk of your work is done, versus those where, that are more interactive or that require you to actually write down the full structure of the proof.
Sometimes the structure of the proof is interesting, and sometimes it's not.
Right. Yeah.
Sometimes you just want it to be proved.
Yeah, like sometimes you truly don't care. Sometimes you don't need to have the mental model of the abacus in your head, right? I think that's a valid thing to acknowledge.
Peter Michael, you had a question?
Oh, no, I'm good. The question is sailed. I'm talking about it in Discord right now.
Okay, cool.
I feel like there's also an aesthetic dimension to this problem. Like I know people who strongly prefer to work in systems where you cannot just apply proof tactics blindly. And then I know other people who just do not care and even prefer to rely on, powerful proof tactics and to ignore as much as possible of the underlying proof structure. I'm not sure how to articulate the aesthetic divide here, but it's definitely there. And yeah.
Yeah. So it definitely exists, and I know this because I'm in the kind of minority camp of preferring Agda over Cog. So, I'm prepared to accept that there is quite a bit of pain in that aesthetic choice while I'm busy writing very boilerplate proofs. But I prefer that, and I'm not entirely sure why that appeals to me, but it does.
Yeah, I mean, I share this aesthetic preference. I prefer writing Agda to Coq, but I mean, I think it's in part because in Agda, if you want to make something trivial, you have to make it trivially trivial. You have to make it you have to make a proof that it is trivial, and then you can use that proof when you want to avoid doing the trivial work. But first, you have to prove that it's trivial, right? Whereas in Coq, you just have to write a tactic that effectively makes it trivial, but you don't have to prove that the tactic works, right? It just has to try something.
Yeah, and there's an interesting question of when you're interacting with a proof search engine, is the proofs that it generates, because quite a lot of the time you are just typing Control-C, Control-A into Agda. That's probably the like most common key binding I am using. But the resulting artifact I'm checking into source control is the thing that was generated and then probably tidied up by the proof assistant. And it seems like the proof search engine is being used in a different place. It's whether you're checking in the output of the proof engine or whether you're leaving the proof engine as something you're going to run every time you reprocess the proof.
Yeah, this gets into these questions of proof reusability and proof engineering. You know, when you change the module that you've proven something about, you then have to redo the proof. I wonder a little bit about the relationship between tools for education, which promote techniques that are good for writing small programs typically, and sort of the question of how those tools are going to scale up. In particular, you know, you can give beginning programmers a lot of contextual help if they're in a hole and you know what type the hole is, and that's great. But if the question the software engineer has is, what architecture should I use here? What should the interface look like? Whose responsibility is it to do X? By whose, I mean which modules, you know, responsibility. Those are not as nicely formed questions. And so I wonder what we can build if we think in that space next, or in addition.
I think we definitely have to, it's also about like decomposing a program into smaller programs, right? Like that's also kind of why I believe that this learning to use holes while you're learning to write a program is important, because it allows you to write your composition, your decomposition of a problem down, and that allows you to write larger programs, because oftentimes beginner exercise, they start like, here are some small problems that you can solve and that we can give feedback on, and then you go on to this larger problem, which is basically just the applications of everything that you did before. But if there's some way to allow the student to write down how they want to decompose a problem and how they plan to do the exercise, and already get feedback on how this is working, I think that's a great start towards larger scale.
Yeah, on the other hand, you know, there used to be a big debate about top-down versus bottom-up programming, right? And I think the answer we've settled on is yes, both. You need to do both.
Yeah.
Right. Like, yes, you need to think at a high level about what structures you need, but also maybe you want to build lower level components and just show that you can actually build them, and then try to think in terms of those. So, you know, this programming by holes is strictly top down, I think. Someone can tell me if I'm wrong about that, but and so I wonder what a top down plus bottom up extension of programming by holes would be. How can we facilitate both directions at the same time?
There are some techniques to fill in holes for the student, so you can like put the student program into a let binding, introduce a new hole, and then you can go on from there. So that way you can have also more like a bottom up approach in some way. That makes sense.
I think, you know, the thing about bottom up programming is that you start with some intuition about a module that might be useful, and then, you know, maybe you actually implement it, or maybe you just write down its interface. And then you say,
that sounds
okay,
like
now
top down to me.
Hmm?
That sounds like top down, not bottom up to me. I'm confused.
Well, it depends where the module that you're thinking of fits in your system, right? Like, if the module that you're thinking about is, well, the bottom. I mean, it's like bottom up, top down recursively, right? Like, for each module, you're going to come up with some interface and then write out an implementation.
Mm-hmm.
So that's top down, but then within some context, you might do that again at a lower level, right? So like, I'm trying to build, you know, the thing I happen to be doing is like a city simulation game, right? So I'm building a city simulation game. Okay, I'm gonna have tiles. What does a tile look like? Okay, let's figure out what tiles are. And yeah, there are gonna be some higher level details about how the simulation goes, but I'm at least gonna need these tiles.
Yeah.
So let's write, you know.
Okay. Yeah, so top down versus bottom up is sort of contextual, like top down in relation to what, or bottom up.
Right. Yeah, exactly.
Okay, so then what would bottom up whole-based programming look like? Well, if bottom up is contextual, bottom up in relation to what?
Well, I think that it's still possible. Just you have your main you define some main program, but you just leave it as a whole, and then you add your more specific function like the tile thing. You add that to your context.
Yeah, it's a stack.
Yeah,
the stack of top-down programs.
Right. Yeah, I think
Like
that's sort
I'm
of
building this thing. Oh, I'm gonna defer that for a minute. Let me work on this lower level thing.
Yeah, I may have been missing something, juggling my attention back and forth between this and the Discord and so on. But I was, or I mean, I guess in my thoroughly, Curry Howard steeped brain, my thought of what bottom up is in this context is, similar to the bottom up logic programming world, wherein you have a set of constructs like library functions and fields and primitives that you can then kind of potentially saturate a space to construct programs of certain types that you expect you might need later, right? You sort of do things without necessarily knowing why you're doing them yet.
Right, you do things speculatively, hoping that eventually they'll be useful.
Right.
So, okay, this is maybe not going to make sense, but what we're saying is that bottom-up programming is using the cut rule.
That's kind of what I think that's kind of what I'm thinking.
It's expecting that later you will use the cut rule.
Right.
Even though you may not be ready to do it yet.
It's proving the lemmas even though you don't know what the theorem is yet.
Right.
Mm-hmm.
But it is notable that the AGDA mode has very good support for top down, but I regularly hit this thing of like, oh, okay, actually, what I want to do is I want to build the thing bottom up for a little bit, and then try to glue what where I'm trying to get to with the thing that I've just built. And like, if you want to do that, you have to do it by hand. You have to take the term that you partially built, go out of the goal, cut and paste it, put the bindings in, blah blah blah.
Yeah.
but
You have to do.
in ACTA you can. In a whole in ACTA, you can just write the name of some function that you define and then use the autocomplete, right? So then,
that helps you build the subterm that you're building bottom up. But there's no mechanism for taking a thing that I'm currently halfway through building bottom up, save it, call it a lemma, make it a thing, and now I'm going to carry on trying to bridge the gap between these.
This is like a classic refactoring, I think. Like the refactoring people have a name for this.
There's something else going on, I think, in proof assistance or proof, like formal context like AGDA, right? So, I mean, I have relatively limited experience with AGDA, but I've spent like several months working with it. And my experience was every time I tried to do this, I regretted it. Right? I'd be top down for a while. And I'd say, well, I'm not sure exactly how to proceed. Maybe if I built this lower level, if I wrote this lemma and then used that, that'll be good. So then I'd spend a long time writing the lemma and a long time proving it. And then I said, okay, great. Now that I've got the lemma, how am I going to use it? And then inevitably, oops, I proved the wrong lemma. Whereas somehow and maybe it's that I'm not as good at it yet, and so I don't have as good intuition for exactly which lemma I want to prove. But I feel like it's, like in typical software development, the connectors are more flexible. And if you build something that wasn't quite right, you can add a little bit of glue to glue it together. And maybe it's not quite perfect, but it's okay. Whereas when you're working in AGDA, there's it can be really hard to write those adapters. And then it's sometimes easier to like rewrite the prove a different lemma. than it is to try to connect these two things, which, you know, didn't quite meet up.
Did it get you unstuck though? Like, so like you wrote the lemma and it was the wrong lemma, but in the process of figuring out that it was the wrong lemma, did you get unstuck on how to solve the bigger problem?
I got unstuck in a way, but because of this impedance mismatch, I found myself wishing I hadn't gotten unstuck in that way.
It was
I found
frustrating.
myself wishing that I hadn't done that.
Yeah.
Just because writing the proofs can be so expensive.
Yeah.
And maybe it's because you know, I was a novice at doing this, and so like I didn't have good intuition for which lemmas should be true. So it takes some iteration to state the right lemma. And then iterate around the proof. And then by the time I'd done that, I felt really miserable when my lemma didn't fit nicely where I thought it was going to fit.
I feel like I kind of had the opposite with when I was working with ACTA. That I usually had some large proof that was just not nice enough to get in one go, and then I started thinking about what other lemmas might be useful, and that was usually the way to get there, and that usually stopped my frustration because I was very frustrated after working a long time on such a larger proof, and once I started using sub-lemmas, it basically solved it for me. But perhaps it's also about what kind of proofs you're writing, of course. It might be very specific topics.
How much intuition you have about, you know, AGDA and proof techniques. For some reason, you all keep talking about auto, you know, control C, control A. It never worked for me, ever. It always said, tough luck, do it yourself.
I've also almost never gotten that to work. So I think we must just be working in a very different domain than Alan.
Yeah.
But it does it for very trivial proofs.
Yeah.
So there and I do find it frustrating. There are sometimes it doesn't autocomplete. Like it can work out that there's a property and its negation in scope. So yay, there is actually the possibility of using proof by contradiction here. But it won't, so that bit will work out, but it won't work out that you need to use proof by contradiction. So you have to say, use proof by contradiction here, and then you can control C, control A. It'll find the two facts and plug them together.
It's also kind of just a shortcut for writing REFL, right?
Yeah, but the time that it's really useful is when you're building a proof tree and the leaf nodes. It can usually work out what the leaf nodes are, and the leaf nodes are half the nodes in your tree. So half the time control C, control A works.
So I have to switch rooms. So I'm going to sign off and then I'll sign back on a little bit, but you all can keep talking.
I've shared a document on Discord, by the way, that I don't want to make it, I might want to share it as viewable at some point more publicly, so I don't want to make it editable by anybody who can have the link, but if you would like to edit it, please just request edit permission and I can share it. But just kind of, I'm trying to collect some of the resources, especially links to outside resources. And I'd like to get a list of people's talk slides and videos as those become available. It looks like Luke is making a list of key phrases that have come up in conversation. So I'd be happy to make this a collaborative project.
Chris, actually, I guess I had a question about your talk.
Oh, sure.
Which is, so you're investigating, or at least one of the things you were investigating is like using logic programming, specifically ASP, to like enable generative creativity.
Mm-hmm.
Have people had like what has people's experience been learning logic programming? Like, have you taught it to anybody who didn't already know it, and what was their experience like in learning it for creative purposes?
Yeah, that's a really good question. I have taught it. So I teach a generative methods course at NC State, which is a special topics course for graduate students that I think is, most of the folks in that class will come in having reasonably, like undergrad levels of programming experience at least. And I think they've mostly figured it out. I like usually, I don't know. I have an approach that starts very, very bare bones. Like ASP has a lot of fancy features, and I try to, I'm again like the sort of minimalist aesthetic for languages. Like I try to kind of distill it to very, very small, a small core, and then gradually build it out. And people have done some pretty impressive projects with it. So I think in practice, at least for that audience, it doesn't seem too bad. But I have also my I guess secondhand experience, talking to other people at the conferences where I publish this work, like digital games conferences. People are like, well, how can you, that syntax is just totally unreadable. Like, how can you expect anybody to understand that? I don't, it's totally unusable. And to some extent, I kind of sympathize with that, because even as I think it's one of those things where it's easy to get the easy parts, but then learning how to debug and figure out what's gone wrong when things aren't going the way you expect it to is often a brick wall for some people, and is challenging even for experienced folks.
Yeah, I think there's this effect where people, or I think there may be an effect where people become okay, I need to think about how to say this. People fixate on the first way they were introduced to programming, and they find it more intuitive than other ways.
Right.
Whereas people with a sort of beginner's mindset may not find a certain thing. I mean, they'll find it unintuitive, but they won't find that as off-putting as someone who has only learned one way of doing things will.
Yeah.
Which I wonder it might be part of the sort of negative reaction you're getting from people. But it's also possible that it's genuinely it's hard to know without actually, what would people with no prior programming experience, what would their experience be? Is sort of, I think, the real test.
Yeah, well, and Michael unfortunately just stepped out, but I know one of the things that Michael mentioned in his talk yesterday was the natural programming experiments approach to language design. And that when I guess John Payne and Brad and whoever else was on that team ran those experiments in the 90s with Pac-Man, the results, if you go and read the thesis, it's fascinating, right? It's the results look like logic programming. They look much more like kind of logical list comprehensions and things like that than they do for loops for explaining a video game's rules. And so that has kind of been encouraging to me as perhaps this is perhaps this kind of thing is not, to the extent that people find it counterintuitive, it might be the ways in which it clashes with traditional programming education more so than the way it somehow clashes with human cognition. I would love for people, honestly, and this is an interesting, maybe something to get towards a research agenda for, this area more generally, I would really love to see some studies that compare how quickly people can learn or can be taught kind of unconventional programming models depending on their level of prior programming experience, right? If you try to teach standard ML to someone with zero programming experience versus to someone with some Java programming experience, what does that look like? What are the differences? I haven't seen anything like that, but perhaps it exists.
Have you seen Kodu?
Yes.
Because when I saw that, I was like, whoa, that is a drastically different programming paradigm.
Yeah, Kodu is rule-based.
Yep.
How do you spell this thing?
Kodu.
Kodu?
KODU,
Okay.
yeah, it was a language developed by Microsoft for programming for kids to learn how to program by making little like Xbox games basically. And it was like whenever Kodu bumps into an apple, then Kodu eats the apple. So just kind of very straightforward, sort of like when do statements. I think kind of based on like the sensor actuator model that was common in robotics was a inspiration they cited. Actually, one of the folks who worked on Kodu as an intern at Microsoft is now my colleague at NC State, Katie Stoley. Yeah, that was a language I looked at a lot when I was developing my thesis language, which was a logic programming kind of grounded approach to a similar kind of rule-based way of writing interactions, including game rules. Kodu is interesting, but it does sort of have this challenge of like you can kind of understand what each rule will probably do in isolation, but you don't necessarily get a great sense for what the whole program is going to do or how the rules interact with each other, because it's like kind of a very kind of not only state change oriented like statements as the conclusions to rules, but also no like explicit semantics for those. So it will say like eat apple. You might have some concept of what that's going to do internally in like the game state, but you then have to reason about, or like move toward, right, is like you're gonna have to reason about the fact that that's going to eventually bring the character near enough to something that another rule whose precondition is near to is likely to trigger, but they're not like kind of directly connected to each other.
I think that's by design, though, isn't it? I mean, it's like it's meant to encourage you to develop systems with emergent behavior.
Right. Yeah. I mean, I think it. To be honest, I mean, it seems like it's been really successful. It's. I think they've discontinued the project for whatever reason, but. But I mean, it seemed effective. It seemed like people were able to use it well, and yeah, it was an interesting approach. I feel like that I haven't seen in a general purpose language quite the same style before.
Chris, to your point about like the time taken for learning language paradigms, I don't know of anyone doing that, but Greg Nelson, who is working with Amy Coe at UW, has a line of work about like teaching programming skills, and in particular focusing on the idea that teaching syntax is orders of magnitude quicker than teaching semantics, or at least writing. So in particular, he focuses on the idea that you can actually teach someone how to read a program productively in a couple of hours. Writing's a different question, but there's sort of an interesting, can you actually teach someone how to read OCaml productively, in a couple hours? Actually, I believe that. But then writing, it's, obviously like, using reading and writing analogies with like literacy, right? Writing is a harder activity than reading. And so that might be one sort of inroads to sort of look at.
Cool. Yeah. That's a good thing to keep an eye on. I just watched one of Amy's talks recently where I think she mentioned some of Greg Nelson's work, but I didn't hear about that study. That'll be interesting to look at.
It's like one of those ideas that like makes sense. It's not obviously correct, but makes obvious sense once you hear it. But I would never have thought of, because the way that we teach programming is always, or the way I've seen it is always, try to get people to do stuff. That's the first thing you do.
Yeah,
not
exactly.
Try to get people to read stuff.
Yeah, I mean, like I take this idea for like when I teach like discrete mathematics, because we do the same thing with like, proofs, right? You learn proofs by writing a whole bunch of them, and then you never actually learn how to read any of it explicitly. So I think it's one of those like, oh man, we've been doing it wrong for a while, haven't we? So
there was a computer science education framework. Unfortunately, I can't remember the person who originally proposed it, but I was just sitting on the dissertation committee for Nick Lytle at NC State, who was doing a bunch of empirical studies about this thing called use, modify, create, which is kind of this principle that there's like it's a good idea that the hypothesis is it's a good idea to teach programming to novices by in stages, where the first stage is use, the second stage is modify, the third stage is create. Use being you're given a complete program, you run it, you ask questions about it, answer those questions, explore what happens, when you do different things in the actual program. Modify is change some of the parameters, change some fairly trivial things, maybe change up some more structural things, and then create is when you have the opportunity to pursue more open-ended construction of something of your own design. And yeah, it definitely seems like, and you're right. I mean, with analogy with reading and writing, it certainly seems like maybe we need more of the kind of use and modify elements in some of what we're doing.
Your description of Kodu sounded quite a lot like if this then that, with a similar kind of set of logical properties of it works locally and reasoning about it. And as the program grows to even kind of moderately sized, it becomes difficult to understand what's happening. Is that an example of a similar semantics, or are they fundamentally different?
Well, I didn't quite catch the name of the system you said.
Sorry, if this then that.
Oh,
it's a kind
yeah.
of end user IoT. Yeah.
Yes. Yeah. I haven't looked at that language in a while, but I think it is similar. Yes. Yeah. I mean, it's just the sensors and the actuators are more like hardware components of your IoT rather than like things that your Kodu can do. Yeah.
Things within your game world. Yeah.
Right.
And they're both like heavily influenced by the guarded command language. So
by the what?
Guarded command language. So Dijkstra, like 90s.
Yeah.
School.
Yeah. Fair. Yeah. Mm-hmm.
Hey, I have an unrelated question about logic programming. I don't know if you remember the like expressiveness benchmark thing I mentioned yesterday, but I had to write a bunch of data log recently. And one thing that I was really struck by was it seemed like to me the core issue that I could not get over in writing data log was that you had to ground your variables in terms of like a concrete data source. So like you couldn't write a generic function. That's the key thing. You could not write a generic like a split string, because the definition of split had to be grounded in the source of the string. It couldn't be parametric over the string. And I just looked this up, and I saw that like general Prolog has like higher order facilities, like a relation can take another relation as input. But is this like a big well-known thing? It just struck me when I tried to do any data log that this seemed like sort of the biggest usability issue. Is like there's a complete inability to abstract without modifying the compiler directly. I don't know if, yeah.
Yeah, I mean that's part of it being decidable.
Yeah, we were talking about this in one of the Discord, I think the other Discord channel last night. Ernst was mentioning this is kind of the motivation for data fun, I think.
Yeah, pretty much.
Oh, cool. I'll have to read it.
Yeah, but this is like, that is a deliberate design decision in Datalog, is to not allow that in order to make Datalog decidable, in order to guarantee that all your relations are finite. But it's also like, why it's hard to write Datalog. Like, you are correct. That's why it's hard to write Datalog.
Interesting.
I mean, there are other problems with Datalog, but that is one of the big ones.
Yeah, because sorry.
Go ahead.
Because it just as a part of this this expressiveness benchmark thing, I've been trying to think about how do you like meaningfully articulate or identify through the data what actually makes one language more verbose than the rest at accomplishing a specific thing. And like for Datalog, for example, it just turned out that in many of the instances where there was a standard library function in Python and SQL, but there was not in Datalog. And so it was simply lots of code to re-implement that standard library function. But that's not really a very satisfying answer in a way. Like I'm interested in more precise ways of talking about like how the programming model offered by Datalog versus SQL versus whatever makes it harder or easier to implement different tasks.
So there's sort of a standard work in this area, which is like the Felizen. I think it's just Felizen. I'm not sure, but some Felizen.
Yeah,
and
yeah.
Maybe somebody else on. Yeah.
Right. I'm familiar with that work. It's just it doesn't really like I have yet to really see a way in which you could apply that framework that would meaningfully explain any of the differences between these things. Like a good example is in my actual benchmark, the data log is best at joins. It is smaller than any other program that is focused on joins. And you know, I'd argue the reason for that is that you represent joins implicitly. You reference two tables, and by virtue of having the same named variable as acting as like a foreign key between the two, it implicitly conjuncts them or joins them, right? And so it's a very concise. It's like the most concise possible way I could imagine to express a join without some sort of like visual syntax. And so that to me, like I don't know how you capture that, but that's like an example of a kind of insight you would want. Is like data log should be better at the rest than joins, and it's because the representation of joins has a smaller form than, you know, and on the other end would be like a Python for loop where you have to like loop and then check the foreign keys, and there's a lot more text that you need because that's what the computational model requires. I don't know how to capture that idea though, although I guess just empirically in the data as a start.
Yeah. Yeah, I don't know how to formalize that idea either, but like that is, yes.
Mm-hmm.
Yeah, and I guess Felizen's notion doesn't capture that because it seems like that doesn't capture the difference between data log and SQL here. Like I suspect that in Felizen's framework, those will end up being equivalent, at least for joins. Because you can, yeah.
So it's 4 o'clock my time, which means we should probably move on to the next section. So this has been really interesting. Thank you all for participating, and especially to those of you who wrote or reviewed. What I was thinking we could do now is kind of try to map out the future for research in this area. We saw a lot of interesting ideas today and yesterday, and I think that sparked a lot of great discussion. And so I'm hoping we can capture that in terms of some sort of proposed research agenda. So I made a Google Doc. I'm going to paste into the chat. I'll put it in both chats so that it's convenient no matter where you are. A document, which is currently completely empty. And my idea is that we can do this a little bit organically as kind of a brainstorming exercise. So I want to start by kind of individually and sort of as a group, because we'll all see the same document, making a list of things that we'd like to see worked on. Not necessarily, things we're committing to doing ourselves individually, but just things that we think the community should pursue. And then we can kind of divide those into topics afterward and maybe split up into breakout groups to talk about each area individually. And then we can come back together and the groups can kind of summarize what they found. Does that sound reasonable? Anybody have any requests or suggestions for our process here? Oh, Jonathan says document is restricted.
Yeah.
Let's fix that. Oh, I see. Okay, try again.
Yes, that works.
The problem with modes and state.
Don't have edit access though, if that's the intent.
Oh, really? Okay, hold on. Boy, everything is hard. There, okay, good. Now everybody should have edit access. Good. So Chris, as you mentioned, Chris has also been working on a document with some notes, so we can reference that for some ideas that we can put in here. So feel free to kind of type ideas that come to you.
As an aside, I did this kind of experiment in a shared doc with like 50 people, and we quickly got the doc out of sync. So I'm curious to see if that's going to happen here.
Okay, well, we'll see.
Well, so far so good. This is great.
If it doesn't work, we'll have to establish conventions like you can type, but only with one finger at a time.
I noticed that Discord, I don't know if they just added this or if I just didn't notice it before, but I just noticed that they have a thing where you can make a channel slow, where, like basically you can restrict posting by a certain amount of time. So you can only make one post per that amount of time.
Excuse me. Accidentally Control-Alt-Delete. That's not going to work.
Does it make sense to put our name by things that we've written?
Sure, you can if you like.
Might be helpful.
Also, I would like at some point to take this document and, clean it up a little bit and post it somewhere. So if you'd like to be acknowledged in that, if you could put your name in the document, you can have maybe a list of authors of this work, so that we can all be acknowledged.
Dominic, if you're there, can you say more about this thing you've added at the end? Interaction modes between humans and programming language tools. There's a bit that I think mostly I added somewhere in kind of the middle of the document that came out of the like voice interfaces stuff. And I'm curious if that's related or if you mean something else.
Yeah, I do mean something else actually. Sorry. More like if you look at what would be the sort of the old way of sort of edit, compile, run, edit, compile, run, versus sort of RECLs versus things like cock, where you can incrementally process the file,
Right.
even if loads of it's broken, or things like with Agda, where you can put holes and synthesize, or things like these live programming environments where you're running and executing, and or like Wrestle, the talk Hilla Peleg's talk at paper at OOPSA this year, where they've got like read, evaluate, synth loop, and I think there's sort of these are like there's different kinds of interaction between the programming language tools and the programmer that kind of go beyond this traditional mode, and I think
cool.
there's a ton of untapped stuff there, and even things like autocomplete is like a kind of program synthesis,
right.
And like the visual and the kind of the small talk style way of doing things, where you're like inside the programming environment runtime itself, and yeah, I feel like. Sorry.
I was just going to ask, would a good phrase for that be maybe programming workflows?
Yeah.
Or does that leave something out?
Yeah, no, I like that actually. Yeah, I hadn't thought of it like that. Yeah. I think what Thomas and I have sort of said is like, there's lots of stuff out there and we don't have a good, is there a sort of framework or paradigm that we can use to kind of express all of the things that are out there? And would that uncover things that we haven't thought of yet?
Right. The kind of mapping a design space to figure out where the empty cells are.
Yeah.
So one term that's used is PX, programming experience. And it's just looking at the interaction between the computer and the human during programming, and thinking of that as the driving thing in the design of a language and an environment for programming. So one example is TypeScript, where we're told that the type system was very much driven by the need for doing auto completion. That was one of the biggest motivators in doing TypeScript, adding types to JavaScript.
Yeah. I mean, this does go into the space of things, Jonathan, that I've heard you talk about, these much more, so these sort of interactive programming tools, the kind of the gap between standard general purpose textual programming and spreadsheets, the sort of stuff in the middle. That's also part of this, I suppose. Yeah.
I mean, the question I like to ask, it's just my own personal question, I'm not sure it's for this group, is whether types are an important theory and mechanism, but whether they actually need to be exposed on the surface of the programming experience, whether live values and witnesses and so forth can fulfill that role.
I like that question.
To add that as a research. You do or you don't?
No.
I don't know.
Seems like you muted just as you were answering the question.
I am an idiot. Yeah, we think about a similar thing in synthesis, right? Does the synthesizer does the artifact that pops out need to be a black box or a white box where you can see the source code? Or do you trust the synthesizer to do the right thing? Do you need to know the implementation if you know that your tools are actually going to generate the program for you? I mean, that's kind of what compilation is, right? You compile a program down to some other form. You don't care what it is. It's there, you can check it, I guess, but in practice, no one ever does. I think you're totally right. You don't necessarily need to surface types, but there is a question about what information we actually glean from it that's interesting to sort of think about.
And that reminds me of this question of what are the boundaries of what it means to have a programming language, right? I mean, to me, you know, the boundary stops where the behavior is no longer defined by the environment that the person is in, typically in a fixed way by a language specification, or at least a language implementation, right? But if you're talking about a natural language sort of environment, which uses some, machine learning to interpret, some text and then, does something as a result, to me, that's sort of outside the scope of programming languages. So you can imagine synthesis being sort of in the middle, where, you write some examples, and then those examples may match, a whole bunch of different candidate programs, not all of which have the same behavior, right? They may have different behavior. So, to what extent is that programming versus is it actually some other activity, which is somehow out of scope?
You reminded me of this, like, I guess I must be new to it, but I think it's an idea that's been around for a while. I've just been like off of social media because of the election. But this whole idea of no code, like being a thing, I was wondering what people's takes were on that. Sort of like, I guess now it's a pop culture idea. I don't know. But it seems to be just kind of riffing off of stuff that, the community's been developing for a while, or at least thinks about. So, and it's exactly this sort of like spectrum between what is programming, what is not actually programming.
Could you elaborate a bit more on this? I'm not aware of this no code thing.
Oh, I was really hoping someone else would explain it.
Oh, it's the latest version of end user programming, but it's typically parameterized for building web apps, something very specific.
Like Wix, is it these kind of tools? Or?
Well, these used to be called 4GLs. Do you remember things like progress? Let businessmen, easily solve their problem without hiring a programmer. It's kind of a lot of things of palettes of reusable components, and it was a big VC funding craze about 6-9 months ago. I think it's already burning out.
Oh, I missed it. Dang it.
Yep, you missed it.
So I wonder if we can maybe think about centering around themes and then break up into smaller groups for discussion. We've got a lot of different topics here.
Yeah, I'm wondering, I don't know what the next step you want to take is, Michael, but I'm feeling like the document is continuing to grow in size, I feel, or I think we're at the point where we probably want to start reconverging, narrow, and like group things together.
One way that I've done this for content analysis in the past is to try and come up with like 1 to 2 tags for each topic or for each like question, where a tag would be like, type systems or mental models or something. And then based on other tags that people are writing, you can try and standardize around a set of words. And then those tags become the clusters by which you can group together the questions. Just a possibility.
Sure, we can give that a try. I think clustering is kind of the right next step. So that's a fine technique.
Lightning round qualitative coding.
Yeah.
Yeah, I've normally done this with 2 people instead of 16, so this will be interesting.
We'll call this ungrounded theory.
Who suggested sketchy formalism? I like that.
Oh, that was me, Jonathan.
Could have guessed.
Sorry.
I like that a lot. I like also informal methods.
I don't know where to put this, but Jonathan, something you were saying about do we need to expose types reminded me of this work by Eric Seidel and others from Splash a few years ago, where they were showing, they had a tool that instead of showing people type errors, they could automatically generate a sort of a trace and a sort of problem that happens because of the type error. So sort of generating a sort of, your problem with the if you put this input in and then this happens down here at this point. So sort of explaining type errors, but without showing type errors, and sort of automatically generating that for, I think it was for Camel. I remember thinking that was
I missed that. Eric Seidel.
Yeah. Let me see if I can just find it. It was probably 2017, I want to say. I think it was his PhD thesis as well. Okay, no, sorry, it was ICFP 2016, Dynamic Witnesses for Static Type Errors. I think it was that. So the dynamic witnesses were the inputs and the examples of the programs that showed things going wrong, but without errors.
Yeah, that's exactly what I was suggesting. Use witnesses for everything. Sometimes witnesses might be somewhat abstract, but they don't need to be fully abstract.
Yeah, so I think that he had a line of work. Also, there was an OOPSLA 2017 paper, but I think it was about something slightly different, but sort of related. Yeah, but I don't know where to fit that into the document. But when you said that, it just made me think of Eric. But.
Well, yeah, I hesitated because I'm not sure it fits in with this document and this research agenda, but kind of my pet peeve. So how are we clustering? Is there a list of clusters we're making, or?
Well, I think I would encourage everyone to try and come up with at least 2 tags for any individual question, just to promote the ease of clustering. And then once every question is tagged, we can see if there's any themes in the, like you sort of compute a histogram across the numbers of tags and cluster it that way is a good way to do it.
If we were doing this in person, I would suggest Post-its, move them around, but it's a little challenging.
Yeah, that's the main thing I miss, or I don't know, not the main thing, but one of the things that I miss from doing things in person is paper prototyping and like physical objects that I can move around with my hands.
You miss that more than the snacks and the coffee?
In the future, this should be
a good contender.
This should be a solved problem with virtual reality. We should all be able to strap on our headsets and throw Post-its around and stuff,
And get our haptic gloves, yeah.
Minority Report gloves.
Has anyone built a tangible formal verification system?
Add it to the doc.
You could argue that people have, and it's called civil engineering.
Well, that's also PX, proving experience.
Oh yeah, Peter Michael, if you're there, I would love to hear sometime about the using sort of computational concepts to teach discrete math project, because I think that's just such a fun and interesting route of this idea of like what a types have to teach us about the rest of the world, and or like structure the way in which we learn other things. And like when I was learning Lean and teaching people about Lean, I was like, this is just such an obviously better way to teach intro to discrete mathematics, is something like a theorem prover, where you can like take, because like all the people I've talked to, like all their bad experiences they have in intro to CS courses are usually because either A, things are like fussily precise in dumb ways and then ambiguous and frustrating ways, or people are like really pedantic about certain aspects of proofs or whatever. And a lot of that's obviated in an automated environment, right? Like you don't need to be fussy because it just matters that your thing type checks, and like everything is exactly as precise as it needs to be in order for it to check out. And so it's like a very, like, I feel like, well, of course it introduces plenty of issues of how do you actually program and write checkable proofs. I feel like it solves a lot of the issues I've seen with intro to discrete math kind of courses.
A lot of times though, those courses
So
are
I worked on the alloy.
who don't have a lot of programming experience, and so then you're stuck teaching them two things at the same time. I'm not sure if that's a good match in that.
But that's the thing. They're not they don't have to be separated, right? To teach someone discrete math is to teach them programming in a way. I don't think you need to teach it as a standalone skill in like my dream version of the world. And maybe that's a pipe dream, but I see in my head a pedagogy that could approach that, but who knows?
You can also teach discrete math with a solver, and I've seen this done with alloy, and the great thing there, looping back on our previous discussion, is that you get counterexamples to your assertions. It's everything is grounded in terms of concrete examples.
Cool. Is that this Charles Wallace, Michigan Tech University, using alloy in a language lab approach to introductory discrete mathematics? I'll put it in.
I hadn't heard of that, but that sounds like it.
I just Googled it, but yeah, this is cool.
Does anyone know Prover 9? I feel like I'm the only person who uses Prover 9. Every time I mention it to people are like, what? What's Prover 9? But it's like I think it's a really nice kind of first order logic tool, but it has a model checker in it. And it's just, I find it's like really easy to use because the syntax is really light. It's great for like exploring things with students and finding counterexamples. Yeah. It's like a resolution backtracking proof search thing, but as a model checker. But it has a really nice interface. Also, basically, I always forget how to use the syntax of stuff like alloy, but Prover 9 I can always remember. So,
Interesting.
One question, by the way, you can ponder in the back of your mind is sort of where should we go with this? Should we do the same thing again next year? Should we do something different next year? Should we propose a dog stool in the future world where that might be possible? What is the right agenda for our kind of research in terms of like mechanically how should we coordinate?
One observation is understanding what niche this specific slice of the community would be most useful in, because there's already Plateau, there's ICER, there's HCI in general, it's there's different there's VLHCC, right? There's different places that people already do, particularly this more general programming experience kind of stuff, live, whatever, and either it makes sense to pick the most relevant sort of venue or set of people and pair with them. Like we wanted to get more CS Ed people involved. You could go like co-host something at ICER. Like for example, Plateau swaps, between Splash and WIST, or they've started doing that. So there's one thing which is like more aligning yourself with a specific community, or more like, honing in on a certain set of problems. I mean, obviously types is sort of the organizing principle and formal methods, but I guess just kind of my observation is like, particularly from the conversation we've had, it's been fairly all over the place and all encompassing with things that could easily fall into other communities. So maybe like trying to be a little more specialized could be a topic of concern.
Yeah, I can see that. All right, so
I just wonder what co-locating means now, and if it's ever going to mean the same thing it used to mean.
Yeah, that's true.
Why, since we're online here, what does it mean that we're co-located with Splash, right? Why not just do this, send out emails and get together and do it? What's the difference?
Well, it's not co-location, but it's still co-temporal.
Co-timed.
And co-community. Like we share a community, right? Whoever registers for Splash has access to this workshop, and if they're just passingly interested in something, they might pop in, even if they wouldn't have found out about it otherwise. In some ways, I think of it more as like a network effect. Yeah.
There's some foot traffic, although it's not helped by the fact that this workshop does not appear, on the front page of anything, right? You have to know how to find it.
Mm-hmm.
It's really annoying that it doesn't appear on the front page of their Clouder thing.
I can see why though, because
but I only attended Splash this year.
But even the talks aren't showing up, right? Or maybe the talks show up.
Yep.
So I have a question about that. I asked about this with some organizers present, and they said, well, basically workshops that didn't want to, participate in the mirroring that Splash did, ended up like this rather than the other way. Is that, is that a choice that we made? Maybe without knowing the consequences?
I don't remember whether we were asked if we could.
Yeah, I don't recall being asked, but there were a lot of emails flying by and I may have missed some.
I don't think it would have made sense.
This year was super hard.
Yeah.
I don't think it would have made sense for us to mirror, because it would have, demanded that we all pre-record our talks, and I think it would have really made it less organic. I can see the argument for that. I think so. One of the things that I did when I was, going through this process is I looked at all the time zones of the authors to see whether there was a time slot that would work for everybody, or at least be not horrible for everybody. And the conclusion was there weren't any authors from Asia or Australia, New Zealand in this particular iteration. And so that meant that this particular time slot kind of worked. And it seemed like it would be better to do that rather than sort of force everybody to record their talks. Or
I agree. I think it works better.
Yeah, I think even if I had been fully aware of the consequences, I probably still would have preferred it this way. And to Jonathan Edwards's point, like I think I keep thinking the same thing, right? Like, why do we really need to organize, do things as parts of conferences right now? Like, I think we should, in some sense, I think it'd be good to take advantage of the opportunity to do more informal kind of online things that are available to the public and free to participate in, and kind of community build in that way. Don't get me wrong, I think there's benefit as well to drawing in the existing audience that attends Splash, and I'm glad that we're doing that, but I think maybe going forward, it might be nice to open it up a little bit more.
Luke has some experience with this from PPIG, right? Because PPIG is independent of conferences, right? It is its own event.
Yeah, that's true. It rests on a historical lineage, though. So it's a very different thing to be starting a new community and to be kind of maintaining a direction that an existing community has. I think most of it used to co-locate with VLHCC once every few years, and may well do again if co-location becomes a thing.
All right, so I have a suggestion. We have a list of tags here that someone made. Thank you. What if everybody gets 3 votes? Put your initials by 3 topics that you'd like to vote for, and a vote means you'd like to participate in a breakout group on that topic.
Oh, there's 4 I want to do. Okay. But yeah, 3 is a good number.
Is there going to be a way to interact with this more later, sort of asynchronously potentially, or what's the plan here?
Hoping we can keep the Discord open, and maybe I was actually kind of thinking we could create a text channel for each of the topics that gets enough votes, and then people can continue discussions after the event as well.
Just I need to go soon. I have a huge stack of marking, and it's getting very late.
Sorry about that.
So I'm a bit torn between, you know, how much do I have to not sleep versus interacting. So I think I might have to evaporate, but it's really interesting discussion. So I look forward to seeing what comes out of it. But if I can interact with this document or do anything with it in any way later, I would. But
thanks.
Yeah, please stay in touch. I mean, I think, you know, at least for the time being, the Discord will stay around. So if you want to chat with anybody else from the conference later, feel free to send a message there.
Cool. Yeah, I might drop back.
Come in.
For hours, yeah.
Create a marking channel on Discord, and you can crowdsource your marking job.
Yeah, Dom,
or at least commiserate with other people.
Currency people.
Sorry, silly question. Which topic did the end user programming end up under?
I think that tag may not have gotten listed. You can add it as a tag, or you could consider it maybe under PX. If you're satisfied with that. Yeah, okay. Adding it as a tag. Good.
There's a design tag, there's a design methods tag, but I don't see anything that was actually tagged as design.
That may have been a mistake. Perhaps whoever, Luke, you can, or did you mean something else by design, or?
I'm just generally interested in design and saw that it referred to, I inferred it as referring to design methods, but maybe it did mean something else.
There's one about
There's also a design methods tag. Should we fold design and design methods?
Yes.
And should we also fold software engineering into engineering, or vice versa?
Yes.
Asking a room of computer scientists to come up with an ontology seems like a very dangerous activity.
What interface means. Let's see, spoke on
Oh, I was using interface to refer to voice interface, embodiment, haptics, fun stuff like that.
Like interface hardware.
Yeah. In the I guess the way that the Game Developers Conferences uses it, there's like the Game Developers Conference in San Francisco has this tertiary event called Alt Control GDC, which is about like alternative controllers or alternative interfaces for games, where people build all kinds of like hilarious like physical constructions that you use to pilot your character in a game, basically.
Now, that does seem like a fun thing to try and replicate within this community.
Yes, I would 100% be on board with that.
There are hardware programming environments for children, like in the robotics kind of space.
We just need them for larger children.
The voting seems to have settled down a bit.
Are we at saturation? So how many are we choosing, Michael?
Let's see, there are 12 of us, 16 of us here right now. If we pick, what do you think, 3 or 4? We could have 4. Design methods, PX types, and education. Or
Sure.
end user programming. Education and user programming are a little bit related, although not quite the same.
Could merge them perhaps. Also, there's a question of how much overlap there is in between these. Now we need a constraint solver to figure out our breakout rooms.
JE, you wanted both design methods and PX. Would you like to, oh, Jonathan, in other words, you want to pick one? If both of those are
design methods, or I'll go with PX then. So should I resign from design methods?
okay, and then Alan, you want to pick one? You're also in multiple spots.
Can we not just
All right,
make the
I will
rooms
try
on
to
Discord
pick-
and let people?
Yeah, okay, I'll go for a PX.
You want to just do rooms on Discord and then people can migrate around?
Yeah.
Yeah, that's okay with me.
Yeah, I think that sounds good.
Yeah, everyone's going to collapse into types at the end anyways.
And do we want to establish a kind of end goal for each group, like to come up with a set of, say, 3 key questions we think people should research, or like, you know, a set of related papers, or is it just more open-ended discussion?
I think that's a good idea. I think we should, people should document their conversations to some extent in, like, should we just use the same document, Michael? Would that make sense?
Yeah, I think that's good.
And I guess, yeah, if you're at a loss for what to talk about, maybe come up with research questions. But if the conversation diverges from there, that's fine too. Oh no, now we have 2 voice channels, name types.
Yeah, I'm fixing that.
Okay.
Okay, and then language design and design methods are no good. I'm going to kill language design.
And formal methods, you mean?
There's one called language design and one called design methods, and they overlap, so I'm going to kill them.
Ah, I see.
Okay. And if people want to mutiny and make their own voice channel, I suppose you can do that too.
Is that true? Does everybody have channel creation roles?
I'm not actually sure.
No, I think only the admins can create channels.
Okay. Okay, so yeah, if everybody could put a list of things that you'd like to see worked on, things that you'd like to work on. If you want to put your name by things, if you want to collaborate on something with somebody and write down what you want to do, we can use this as an opportunity to start future projects or latch on to existing projects. I know there's already discussion about maybe people joining in with Hazel, which I think is great. So we can use this as an opportunity for that sort of coordination.
Sorry, what we're doing that in the Google Doc, or we're doing this in the Discord chat?
The Google Doc, so that then it's persistent and organized.
Here, let me make some sections. So the specific things we've created are types. Can you read them out?
Yeah, types, design methods, and PX.
Okay. So yeah, I'm gonna add list of participants and research questions just as stubs for people to fill in.
Excellent.
Okay, so where are we doing the breakout rooms?
Discord.
Okay, could you paste the URL for the Discord in the Zoom?
I can send an invite link. Yes. There.
Thanks.
Sure.
All right, I'm gonna quit Zoom. I'll see you in Discord.
Okay. Thank you all.